Okay, let's look at how to build or construct a polynomial now that has irrational zeros. Now, the first important thing we need to know is that when we're dealing with a polynomial that has rational coefficients, if we have rational coefficients, then irrational zeros, you need to know this, irrational zeros. By the way, irrational just means they've got a square root in them, okay? Now, that's not a technical definition. That's as far as it applies to this video. I don't want to get into the whole number system. So we're just assuming irrational means square root, okay? So square root of 3, whatever. Square root of 4 is not irrational because the square root of 4 is just 2. You don't have to write it with a square root. Okay, but anyway, irrational zeros come in conjugate pairs. So we'll illustrate that through examples. If you have an irrational zero, its conjugate has to also be a 0. Okay? I'll motivate the idea real quick, trying to make this video as simple as I can, but I also want to be thorough. So if you look at the quadratic formula, you get negative b plus or minus the square root of something over 2a, okay? When you get irrational zeros, those with a square root, you get them as the result of a quadratic formula, okay? So this is a basic idea. And you can see that the square root has a plus or minus in front of it. So you typically get two answers out of the quadratic formula. One of them has a plus in front of the square root and the other has a minus. And that's precisely what we mean by conjugate pairs, okay? So let's illustrate what I mean precisely with this statement. So let's build a polynomial. This is an example. Build a polynomial of smallest degree that has rational coefficients. That's what's going to tell us that if I've got anything irrational, I better build in its conjugate pair, okay? So build a polynomial of smallest degree that has rational coefficients and 4 and the square root of 3 as zeros, okay? So I've got 4 and the square root of 3 as my zeros. I want this guy to have the smallest degree and rational coefficients. So 4 is already a rational number. I don't need to do anything with him. So I'm gonna list my zeros more formally now. 4 has to be a 0. And if I want the smallest degree, I'm going to assume that 4 has a multiplicity of 1 to keep the degree small. The square root of 3 is a 0. Now that is an irrational 0. To ensure that I get rational coefficients, I've got to build in the conjugate of this. We'll look at that in a moment. But to keep the degree small, I'm going to assume this guy also has multiplicity 1. Now, what is the conjugate of this? Well, if you think about the square root of 3, like with the quadratic formula, this square root is a positive square root of 3. So its conjugate would have a minus square root of 3. Okay, this is the conjugate of the positive square root of 3. It is not given to you in the problem, but you have to know to build in the conjugate to ensure that together they're going to give you rational coefficients. Again, to keep the degree small, we'll assume multiplicity 1. Sorry, my red marker seems to be running out. Okay, so that's the big idea here. When you've got irrational zeros and you want rational coefficients, you've got to build in conjugate pairs. All right, let's get down to building the polynomial now. 4 is a 0, which means x minus 4 is a factor. Positive square root of 3 is a 0, which means x minus positive square root of 3 is a factor. And negative square root of 3 is a 0, so x minus negative square root of 3 is a factor. So now we want to multiply these guys together to get our polynomial of smallest degree. However, I notice that I've got x minus a negative square root of 3 here. So I'm gonna go ahead and rewrite that as x plus the square root of 3. And you can multiply the three factors in any order that you want. I'm going to take, and I'm always going to multiply my conjugate factors first, because I know when I multiply conjugate factors, all the stuff in the middle disappears. So here, I'm going to take x times x, which gives me x squared. And then I'm going to have a positive square root of 3 times x and a negative square root of 3 times x. They cancel because those two factors are conjugates. Last, I'm going to take my negative square root of 3 times my positive square root of 3. So if you have, maybe I'll write it over here on the side for you. If you have a negative square root of 3 times a positive square root of 3, that's the same thing as negative square root of 9, and the square root of 9 is just 3, so you get negative 3. And really what you want to start to think of is if you multiply a square root by itself, think of the square roots. Let's write it out again. If you multiply a square root by itself, think of the square roots canceling, so you just get negative 3. Okay? Square root of 3 times square root of 3 just gives you 3 every time. Okay, so over here I've got x squared and I've got minus 3. I've still got to multiply that by my x minus 4. So I'll go from highest degree term to lowest. So x times x squared gives me x cubed. Okay, so there's my x cubed term. Then I need all my x squared terms. The only way to get an x squared term is to multiply by negative 4 by my x squared. Then I'll get all my x terms. I can get that by multiplying x times negative 3, and that's the only way. So that's negative 3 times x. And then my constant term is negative 4 times negative 3, which is positive 12. So look how fantastic this is. We started with an irrational 0, but in our final answer, we got rational coefficients. No square roots there. Okay? In fact, we got integer coefficients. We got whole number coefficients. We don't have any fractions. Fractions would have been okay with rational coefficients, but we didn't even get those. So by building in the conjugate of the irrational 0, we ensured that when we multiplied, that this process here would happen and all the square roots would go away. Let's do another one. Again, the emphasis here is that irrational zeros come in conjugate pairs if you have to have rational coefficients. Okay. All right, so let's look at our next example. Determine a polynomial. Let's say it's different this time. How about determine a rational coefficient polynomial. It's kind of a weird way to say that. Just trying to save some time and space here. Determine a rational coefficient polynomial of lowest degree with negative 2 as a 0 of multiplicity 2, with negative 2 as a 0 of multiplicity 2, and 1 minus the square root of 5 as a 0. Okay? So we'll take the same approach here that we did last time. Let's make sure we have a comprehensive list of the zeros. So we've got negative 2 as a 0. Negative 2 is a 0 with multiplicity 2. And 1 minus the square root of 5 is a 0. And to keep the degree down, we'll assume multiplicity 1, since it doesn't specify. But we do want lowest degree. And then, because we need rational coefficients, and I've got an irrational 0, I need to build in the conjugate of this guy. And you can see I've got a negative in front of my square root. So the conjugate of this guy is going to be 1 plus the square root of 5. And we'll also assume multiplicity 1. Okay? So I've got negative 2 multiplicity 2 1 minus the square root of 5, and 1 plus the square root of 5. Now this one's going to take some space, and I'm going to try to show you the shortest way to possibly multiply all this together. So I'll erase all this to gain some real estate here. All right, so we had negative 2 was a 0 of multiplicity 2. So I'm going to have x minus negative 2, which is the same thing as x plus 2. And because it was multiplicity 2, I'm going to put it twice. Then I have 1 minus the square root of 5. So I need x minus the whole thing, 1 minus the square root of 5. And these are going to be tedious to multiply, you can imagine. And then I have the conjugate of this, 1 plus the square root of 5. So the factor is going to be x minus 1 plus the square root of 5. Now the biggest mistake I see students make here is to do the plus or minus in the wrong spot. The conjugate zeros is where the plus or minus happens. Your factors are always x minus. Remember, this was x minus negative 2. That was simple, so I just changed it to x plus 2. Okay? But if you're afraid you're going to get that mixed up, then always start out by writing x minus. All right, so we have to multiply all of this together. So I'm going to try to do this as quickly as possible, show you the most efficient way to do this. I'm going to go ahead and multiply these guys together, which gives me x squared plus 4x plus 4. That one's simple. And before I multiply these guys together, I'm going to rewrite them because I've got brackets and parentheses. So to take care of that, I'm going to go ahead and distribute the negative and get rid of some of this. So this is going to turn into x minus 1 plus the square root of 5. Okay, those three independent terms. Here we get x minus 1 minus the square root of 5. Okay? And this x squared plus 4x plus 4 is just kind of hanging out there waiting on these guys to multiply together. All right? Now, if you want to multiply these two trinomials now, the most basic way to do it, not the fastest, but the most basic way to do it is to take the x and distribute to all three terms. Take the negative 1 and distribute to all three terms. Take the positive square root of 5 and distribute to all three terms, okay? And that will work. When you multiply these two guys together, because they have the conjugates in them, right? The two conjugate zeros. When you multiply these together, there should be no more square roots. We need to have rational coefficients. So if you multiply these together and some of those square roots don't go away, you made a mistake for sure. But the most basic way is just distribute all the terms. The faster way is this. Take advantage of, after you've gotten rid of the parentheses inside parentheses, take advantage of the fact that these guys are conjugates. And so you have to kind of reorganize in your head. When you do that, think of taking x minus 1 as a term, okay? And think of taking the square root of 5 as its own term. So we've got positive square root of 5 and we've got negative square root of 5. So you can see now I've got x minus 1 plus the square root of 5 and x minus 1 minus the square root of 5. Those are conjugate factors. And we know that when you multiply these together, all the stuff in the middle is going to cancel. So what I'm going to do is take x minus 1 times x minus 1. I'm going to distribute x minus 1 to both of the green circles here. And x, if you need to write it out, x minus 1 times x minus 1 is x squared minus 2x plus 1. So that right there alone gives me x squared minus 2x plus 1. And then when you continue to distribute, you're going to distribute this x minus 1 to the negative square root of 5, and you're going to distribute this x minus 1 to the positive square root of 5. They're exact opposites. X minus 1 times the negative square root of 5 is going to add to x minus 1 times the positive square root of 5 to give us 0. That's what happens when you multiply conjugate factors. So we don't have to do any of that. So all that's left is to take the positive square root of 5 times the negative square root of 5. And if you recall, positive square root of 5 times negative square root of 5, well, that's a negative number, right? And the square root of 5 times square root of 5 is just 5. No square root anymore. So I get negative 5 when I multiply my two square root terms. Now, if you're having trouble seeing this conjugate stuff, if you're having trouble with that, the best thing you can do is distribute the x to all three terms, the -1 to all three terms, and the positive square root of 5 to all three terms. It's more tedious, but you want to get it right. So pick what's going to make the most sense to you. This is certainly faster, but if you don't get it, then it's not worth it. So that's all we get when we multiply all this mess together. And now the x squared plus 4x plus 4 is like, okay, thanks guys, finally, I've been hanging out here. Now we multiply this trinomial by this trinomial. I'm going to go ahead and I'm going to cross out my plus 1 minus 5 rather than writing a whole other step, and I'm just going to write minus 4, okay? So I've got x squared minus 2x minus 4. Now, there's no shortcut for multiplying this, really. I'm going to use the same logic I have on every other problem. I'm going to go from highest degree to lowest degree. So the highest term I'll get is x to the 4th. Then I'm going to collect all my x cubes. So I can take this x squared times negative 2x. So that's negative 2x cubed. And this is positive 4x cubed. And that's all I can do. So we've got negative 2 plus 4. That's positive 2x cubed. Then I'll repeat the process for my x squared terms. So I can take x squared times negative 4. So that's negative 4x squared. I could take positive 4x times negative 2x. That's negative 8x squared. So I've got negative 4, negative 8. That's negative 12 so far. Plus 4x squared. So I've got negative 4 minus 8 is negative 12. Plus 4 is negative 8x squared. Write out as much as you need to here to get these right. I'm trying to show you the shortest way you can do it. That way, if you catch on, great. If not, write it all down. Okay, now I've got to do my x terms. I can't use x squared and get an x term, but I can use 4x times my negative 4. So 4x times negative 4 is negative 16x. And then here I've got 4 times negative 2x. That's negative 8x. So I've got negative 16x, negative 8x. That's negative 24x. Finally, the easiest term is my constant. That's positive 4 times negative 4, which is negative 16. Okay? I'm going to double check my x squared term really quickly because I can't remember if I mistakenly used the 1 here instead of my negative 4. So my x squared term, I have negative 4x squared, negative 8. That's negative 12. Okay, good. So this is a polynomial of lowest degree that has negative 2 as a 0 with multiplicity 2 and 1 minus the square root of 5 as a 0.